All right, guys. Hope everybody's having a great evening. Wanted to record a video. Level 3, problem number 1 says 1 minus sine x over cosine x equals negative cosine x over 1 minus sine x from negative infinity to infinity. On this problem, we would want to, first of all, replace the sine and cosines, right, with s's and c's. So this goes to 1 minus s over c equals negative c over 1 minus s. We then want to cross multiply. So we get 1 minus s squared. 1 minus s times 1 minus s is 1 minus s squared. Equals c times negative c is negative c squared. This side needs to be simplified using the box. 1 minus s times 1 minus s gives me 1 minus s over here, minus s and plus s squared. So I've got 1 minus 2s, here are the two s's, plus s squared equals negative c squared. I then want to add c squared to both sides. So I've got 1 minus 2s plus s squared plus c squared equals 0. S squared plus c squared, as you know from your Pythagorean identity number 1, is just equal to 1. Sine squared plus cosine squared equals 1. So I now have 1 minus 2s plus 1 equals 0. 1 plus 1 is obviously 2, so 2 minus 2s equals 0. Let me rewrite over here. 2 minus 2s equals 0. Add 2s to both sides, so 2 equals 2s. Divide both sides by 2. 1 equals s. So where does sine equal 1? Sine equals 1 at pi over 2. But of course, because the interval is from negative infinity to infinity, we want to add 2 pi k. And of course, we'd want to write, of course, I left this off. Let me add it in, right now. We'd want to write where k equals any integer. Let me give you a panoramic view of everything. And the key was we saw fraction equal to fraction automatically means cross multiply. We see a binomial squared, tells us to do the box. Simplify, use a Pythagorean identity here, and solve out. Remember to have the k because we're going from negative infinity to infinity. And of course, add where k equals any integer. All right, guys, signing off. Hope you guys have a great night. I'll be sending an email as well. Bye-bye.